Importance of ethics in networking. Ethics refers to the set of moral principles that govern behaviors and decisions. In the context of networking, professionalism includes confidentiality, integrity, and accountability. Ethical behavior ensures fair access, reliability, and protection of information systems. Consequences of unethical practices in networking design. The first one, security breaches from careless or malicious configurations. If a network device like a router or firewall is configured without proper security settings, hackers can easily gain access to sensitive data. For example, using weak passwords or forgetting to update default settings can allow attackers to infiltrate the system. In some cases, insiders may deliberately create vulnerabilities to exploit the system later. Second, legal consequences such as fines or termination from academic or employment positions. When someone misuses their access to IT resources, such as installing unauthorized software or leaking confidential information, they may face serious legal action. This could include being fined under cybersecurity laws or being dismissed from their job or university. Organizations have strict policies to ensure responsible use of technology. Third, damage to reputation of individuals and institutions. A single incident of a data leak or unethical behavior can harm the trust people have in a company or university. For instance, if a university's student data is leaked due to poor network security, students and parents may lose confidence in the institution's ability to protect them. The same applies to employees and customers in a business environment. Real-life example. A technician using network access to monitor private employee emails without consent. This is an example of abuse of power and breach of privacy. Although technicians have administrative access, they are ethically and legally required to use it only for maintenance or troubleshooting. If they read personal emails without permission, they could face disciplinary actions, lawsuits, and loss of their job. Simulation versus real-world networking. So let's look at the purpose of simulated environments. The purpose of simulated environments are for training and planning. Simulated environments are useful for learning without the risk of damaging real systems. For instance, students or new technicians can practice configuring routers and switches without affecting a live network. These environments also help in planning a network layout before physical implementation. Simulators like Cisco Packet Tracer provide safe environments to learn concepts. Beginners can visually understand how devices like switches, routers, and PCs interact. For example, they can see how data travels between two PCs when a ping command is used. This builds their understanding of basic networking principles. Second one, test configurations. Before applying settings in a real network, users can experiment with IP addressing, VLAN setup, routing, etc. For instance, a student can test whether their static routing configuration allows devices in different networks to communicate properly. The third one, predict network behavior before physical deployment. Engineers can simulate a full network to observe how it will perform. For example, if they want to implement a new security policy using ACL, Access Control List, they can test it in the simulator to ensure it doesn't accidentally block necessary traffic. Next, we should consider limitations and risks if the software is misused. For example, hacking, intrusion attempts. The first one, over-reliance on simulation results can misguide real-world decisions if limitations such as no packet delay, perfect reliability are ignored. This is because simulation tools like Cisco Packet Tracer often provide ideal conditions, no packet loss, no unexpected traffic delays, and devices that always work perfectly. However, in real networks, things go wrong. Cables might be faulty, wireless signals can be weak, or there might be interference. If a network planners assume that a simulation result will exactly match real performance, they might face serious issues after deployment. For example, a student configures a wireless network in Packet Tracer and assumes good performance, but in reality, the network is slow because of signal interference not shown in the simulation. Additionally, simulation software could be abused for unethical purposes such as simulating malware injection. A user might create scripts or network behavior that mimics how malware spreads using the simulator as a testbed to later deploy malicious code in real networks. For example, simulating how ransomware can block communication between servers to prepare for a real cyber attack. Second, crafting social engineering attacks. Attackers could use simulations to test phishing tactics or deceptive messages within a controlled environment, learning how to manipulate users or systems. For example, creating a fake email system in simulation to see how users might respond to a password reset scam. The third one, unauthorized penetration testing. Even though penetration testing is useful for finding network vulnerabilities, doing it without permission, especially in academic or workplace settings, is unethical and possibly illegal. For example, a student tries to hack into a classmate's virtual lab without consent to prove a point. When doing simulation, cybersecurity and data privacy also should be considered. Simulating secure networks responsibly. When using tools like Cisco Packet Tracer, it's important to include security features in your simulations to develop good practices. First, use password protection, ACLs, and firewall configuration in simulations to practice secure design. For example, configure router and switch passwords, apply access control lists, ACLs, to limit access to specific IP addresses, and use firewalls to block unnecessary ports. This helps students and trainees understand how to protect a network from intruders. Second, incorporate VPN and encryption techniques in advanced simulation. In more complex scenarios, simulate virtual private networks, VPNs, to see how encrypted data can travel securely across public networks. For example, two branch offices are connected via a VPN tunnel to secure the communication between them. Next, personal data awareness when designing networks. Maintaining ethical standards during simulation work is important, especially regarding data privacy. Avoid using real user information or sensitive data in simulation. Do not input real names, emails, or identification numbers when configuring devices. For example, instead of using Ali bin Zain at company.com, use user A alias or at example.com. Similarly, when documenting networks, replace real names with aliases. Use generic labels such as user1, student PC, or finance server to protect identity and simplify documentation. Last but not least, password and access control simulations. Practicing secure access configuration in simulations help reinforce good habits for real deployments. Use role-based access control RBAC where possible to assign different access levels to users. For example, only allow admin users to access device configurations, while other users have limited read-only access. Set control and VTY, telnet or SSH password on routers and switches.